ওকে স্যার, আমরা কি অ্যাসাইনমেন্ট হিসেবেও লিখবো না জাস্ট হলো আমরা
No.
প্রেজেন্টেশনের স্লাইড তৈরি করব?
If you can make the presentation slide, then it's a presentation slide. But in some students, they may not have the facility for making the slide. So for them only, they can write the presentation slide as assignment. But the main purpose is you make a presentation slide and give it an email to me. But suppose one or two students right now in this lockdown situation do not have the presentation slide, so they can use their mobile phone, use the information, get the information, and write the assignment by their own writing. Okay, so I think it is clear.
ওকে স্যার।
Okay, so so that will be
সাবমিট করতে হবে কবে?
next week.
নেক্সট উইক। ওকে স্যার।
Next week you have 7 days in your hand, exactly probably 23rd June it will be. Okay, so let's start. Today we will discuss that how the nuclear power plant works, and what are the benefits, what are the disadvantage, and also one or two exam mathematical problems also. So at first you give your role in the chat box. So today's class will be a little bit theoretically, but we also solve one or two mathematical problems. Everybody will give you a role in the chat box. So interestingly, in the last semester we discussed steam power plant. So I believe that you already have the proper idea how the steam power plant works. So you might be happy to know that the nuclear power plant is nothing but extension of steam power plant. So if you understand how the steam power plant works, you already got the 50% of it. Okay, so there is quite a bit similarity with the steam power plant operation, that it also uses the water and also makes steam, and the steam finally runs the steam turbine. But where is the change? The change is basically, I'm giving you this slide. This is nothing but the cut and paste from your book, so you don't need to worry about that this is something outstanding. It is just a cut and paste from your book. So where is the change? What I'm talking about, the change is basically happening here only in the fuel section. Okay, so in the steam power plant we basically use the coal and oil or gas as a fuel to burn the gas and make the steam. But in nuclear power plant we basically use the fission reaction, FISSON, the fission reaction, which basically generates from the heavy elements such like, we all know that uranium or the thorium, okay, though has a high atomic mass. So because these type of atom or this type of element make when it is got broken, they make huge amount of heat energy. So using that heat energy, basically the steam has been produced from the water. Okay, so the basic concept is quite similar to the steam power plant, but there is a different concept of giving heat. So in the steam power plant we give heat by burning fuel, but in this situation we will give heat by occurring nuclear fission reaction, and the byproduct of the fission reaction is heat. So we will use that heat to produce steam. Okay, and the reaction is basically done in the in a particular space that is known as reactor. You all know, so that's why it's a very dangerous zone. We all know that how much the dangerous this reaction can be, because this is also known as chain reaction. If it starts, it's very tough to stop this reaction. So always there are several stages of security to get it much more protected from the outer space. So that's why one important thing before establishing a nuclear power plant, that you have to build this type of power station from the from the living area. where the most of the people lives, you cannot establish there. There should be a, a fixed safety radius area where on that zone the people cannot live. So that's why in Bangladesh also we have recently started to develop a nuclear power plant that is known as Rupur power plant. You may already be known that one of your ex teacher, your our ex faculty member, Mr. Kazim Hossain sir, has already working there on. So it is situated in such a position that there on that area hardly any people lives. I mean, the normal living people. So because that is for the security purpose. Okay, so that is for the security purpose. That is one of the important thing for the nuclear power station. The establishing should establish in a remote zone that the people, less people are living there. And also one more interesting or one more important factor is that the byproduct after the nuclear fission reaction, what will be the byproduct? What will be the wastage? Where will it will be disposed? So in Bangladesh, we are planning to dispose in the in the uh, Indian Ocean, deep Indian Ocean to dispose this material wastage. We don't know that how they will do, but we have done a contract with the Russian company. So they have told us that they will take those and dispose those on the deep ocean. So let's see what happened there on, because it is not still in the still not in the operation right now. If still you do not give your role in the chat box, please drop your role in the chat box. Okay, so let's start that. The definition is that a generating station in which the nuclear energy is converted into electrical energy. That's how I already discussed that basically when this reaction is going on, that is known as the nuclear fission reaction. A huge amount of heat is generated, and it is basically done in the nuclear reactor where the nuclear fission reaction is taken place, and that heat energy is utilized to make steam from water, and finally the operation is same as the steam power plant. So that is the difference between the nuclear power plant and steam power plant. And there is a very important feature that in the nuclear power plant you can get a huge amount of energy or huge amount of electric power by using a small amount of fuel. That is the one of the key features of this nuclear power plant station. Okay, so there is one statistics here given here that you see that to complete fission 1 kg of uranium, that means only 1 kg of uranium element can produce as much an energy by burning of 4,500 tons of high grade coal. That is top level coal, the top graded coal. Also 4,500 tons. Tons means, 1 ton is 1,000 kg. So basically, a huge amount of, fuel energy. So if you just multiply with this 4,500 with 1,000, huge amount of, energy can be produced just by 1 kg of uranium, just 1 kg of uranium. So you can relate that the how much prospect is here, but still uh, everything has a pros and cons. So we can from the outer side we can say that is a huge energy, huge prospect, but still it's a very much dangerous, very huge dangerous for the whole world, for the humanity, because if this kind of power station get busted and exploded, the humanity will not exist a single portion of area. So yeah, this is also very dangerous side. So there is pros and cons of this nuclear power station, but unfortunately the rest of the world are going away from this type of establishment. They are not getting they are not emphasizing the nuclear power station, but as a underdeveloped or developing country like Bangladesh, we have taken that risk. That is quite it was unnecessary, because as a technologically we are not developed that much. So so I don't know what the government has thought, but still, the risk factor is very thin, huge risk factor. But without risk, you cannot get. So if you tell the main major four stages in the nuclear power station, it will be the main thing of the nuclear power station is nuclear reactor, where actually the nuclear fission reaction is happening. The nuclear reactor is the main core or main part of the nuclear power plant. So when the nuclear fission reaction is done, a huge amount of energy is generated. That energy is transferred from that reactor to a heat exchanger, where the heat exchange, this high amount of heat is transferred, and finally using that heat we get steam, and steam gives the steam turbine rotation, and finally we get the alternator, basically the generator, where we get the energy. So basically in the nuclear reactor, the fission reaction is happening. It is also known as chain reaction. We probably know that a high speedy neutron is basically give heat to a uranium atom, it the core of the nucleus of the uranium got broken, and it produces proton and neutron. So it produces suppose three more neutrons. So this everyone also hit, also makes three. Then they also makes three. So it looks like a chain reaction. So it's a very dangerous reaction. Once established, it's very tough to control, and also very much risk to control. So you already know that what is chain reaction. The nuclear fission reaction, once it started with a high speedy neutron and hit the nucleus of the uranium, and it also produces the high speedy neutron. Then those neutrons hit others uranium, produces neutrons. So this is going on. It's like, it looks like a wave. Okay. So as I discussed that the main component of nuclear power plant is the nuclear reactor, and where the nuclear fission reaction is happening. After that, the heat exchanger, and finally the steam turbine and alternator, you get it. So this is
হচ্ছে গিয়ে ফিশন, আমরা ফিশনটাকে মানে কোন এক সময় আমার মনে হলো যে আমি হচ্ছে গিয়ে এটা অবশ্যই অফ করে দিব, যেহেতু এটা পাওয়ার জেনারেশনের আমাদের নির্দিষ্ট একটা জিনিস, মানে আমাদের লোড যদি এর থেকে বেশি না হয়, মানে আমি এতটুকু পর্যন্ত হচ্ছে গিয়ে আমার পাওয়ার লাগবে। এখন আমি যদি এই ফিশনটাকে অফ করতে চাই তাহলে আমি অফ করব কিভাবে?
Okay, there you mean that what is the way of controlling it?
Yes sir.
Yeah, there is a way of controlling. I'm getting discussed. Next slide. So you'll get your answers soon. So as I'm always saying that to control this kind of fission reaction is very tough. I didn't say that it's impossible. It's very tough and also very risky. But there is a way. There is a way, but it becomes very tough when it gets uncontrollable way. When something major mistakes happens there, then it becomes uncontrollable, and we can see some of the explosion in this kind of nuclear power plant in the foreign countries. But I will give you answer very soon. So you see that this is the nuclear reactor part, where the heat is generated, and that heat is transferred using a metal. Basically, the sodium has been used as a as a medium of movement, where the sodium absorbs the heat energy and gone through the pipe, and here the water was there, and water just even acts like a water tube boiler, something like a water tube boiler. Not water tube boiler, it is a fire tube boiler, something like that. Okay, goes inside and the outside is the water. So here the steam is generated. Finally the steam gives into the turbine, and then the alternator. So this is the schematic diagram. Okay, the schematic diagram of the nuclear power plant. You can understand the four major portions: the reactor, the heat exchanger, and the turbine section, and also the alternator section. There are the four main component of the nuclear power station. But here the main importance should be given in the nucleus reactor. Okay, so now in the next slide we will discuss that what is nuclear reactor, how it works, or what are the components there. So this is much more closer look of the nuclear reactor. it says that there are, if we say that this is the heat exchanger part, and this is the nuclear reactor part. So basically the connection of heat exchanger is basically with the nuclear reactor, because here the heat is generated and transferred to the you know heat exchanger. So basically you see that these are the uranium bars, these black lines, these are the uranium bars. Okay, so these are the uranium bars. There are three things available in the uh, nuclear reactor. One is the uranium bar, definitely, where that is considered as a fuel. The next one is the graphite bar, that is also known as moderator. And finally the control rod, the radium control rod. Okay, the radium control rod. So it is known as control rod. Why? Because it controls the speed of nuclear fission. Okay, it controls the speed of that. The one student just asked that, sir, how we can control when we need to stop at that time, how to stop that fission reaction. But one information I must share with all of you, that something like diesel power station or steam power station, the amount of load or the demand can vary or fluctuate. Okay, so we used to vary the demand, and the production of electricity we made fluctuate. But it is in terms of nuclear power plant, the load or the production hardly varied. So it is basically used for the fixed load. Okay, so it is not varied so much, so frequently it is not varied. So almost the load is almost remains almost quite same. But yeah, still it is possible, but it is, we know that we do not need to mess with the dangerous task. So that's why. And there are three things I already discussed. One is uranium bar, the next one is the moderator or the graphite bar, and finally the control rod. So uranium bar, you all know that these are the fuels. The graphite bar are the moderator. You can understand from the word of moderator. Moderator means who moderates, moderates the process. So basically graphite bar is basically used to control the speed of neutron, because when the reaction happens, the speed of neutron atom or neutron particles are too fast. So to slows down them, in a certain position, in a certain value, the graphite bar is used. So it basically controls the speed of the neutron, but it doesn't have any control of the closing or increasing the rate, which does the control rod, that is the radium. So basically radium rod or this type of material are huge neutron absorber. Okay, huge neutron absorber. So suppose when the nuclear reaction or fission reaction happens, there are so much neutron here and there, so much neutron here and there on. So as I said, that this kind of control rod are neutron absorber. Okay, neutron absorber means uh, it absorbs neutron spontaneously. So when you need to slow down your fission rate or slow down your process, you can use this control rod. So when you dip the maximum portion of the control rod, it will automatically absorb the neutron, so it will slow and make it slow. But when you suppose you put off the whole bar here, so there is no controlling here, so you are not absorbing anything. So basically by putting it down and up, these are acts as a control rod, and also give us the opportunity to control the the reaction rate. If you want to slow it down, if you want to make it a smaller rate, so that's why the control rod works. I think you got your answer. So basically how it works, it is a neutron absorber. So when you dip more, it absorbs more. When you do not dip more, or maximum portion is outside, it absorbs less. So that's how the absorption of neutron controls the overall chain reaction, or the the nuclear fission reaction. I think you understand. So here, other parts is the coolant, basically the medium. Basically, I discussed already the sodium metal. So it is here and there on. So when the fission is generated, the heat is generated. So the sodium absorbs the heat, and it goes there on the heat exchanger. Heat flows here, and you all know that the higher amount of heat particles gives or releases heat to the lower amount of heated uh, particles. So basically, the sodium releases the heat to the water, and from water we know that it absorbs the heat and becomes the steam. So the steam is light also in weight, so it goes to the upward side, and finally we use that steam just like the steam power plant. So again, this coolant is pumped back to the nuclear reactor again. So it looks like a circle. It takes heat, releases heat, again goes there and takes heat and releases heat. This is the overall operation of the nuclear reactor. So if we go to the next slide, the everything I discussed here, it is written um, clearly written clearly. Cadmium or sorry, the metal was cadmium. Okay. It's not radium, sorry, the cadmium. Basically, the cadmium is a strong neutron absorber. You can say that here. The cadmium is a strong neutron absorber, thus regulates the supply of the neutrons for fission. So that's how the control rods are pushed into deep enough, so they absorb more neutrons. So when they're not deep enough, they absorb less neutrons. So that's how we control the speed of nuclear fission reaction. So going back to the next slide, these are the advantage and disadvantage will be the next slide. The advantage is definitely, if we discuss in total, definitely the amount of fuel will be less. We discussed at the very beginning, the amount of fuel will be very much less. And also, when you produce so much energy from a small amount, so that should be economical also. But and it is ensures the reliability of the operation. That means that if you can establish it properly, it is quite reliable if any big mistake is not done. So these are the advantages. I shouldn't read line by line. You can easily, right? But these are the advantage. There's some disadvantage also, because I already discussed that only 1 kg of uranium is equivalent to 4,500 tons of coal, high graded coal. But still, the availability of uranium is also not, it's too easy, just like coal. It is too expensive. You have to pay a huge money. You have to spend. You can just have a look from the Iran, what they are doing. They are they're collecting uraniums. They're collecting uraniums, and also it has a regulation that you cannot collect, or you cannot preserve uraniums um, on a large extent. There are some rules and regulations in the whole country. So that is also a concern. And also you have to pay some more bucks. And also, the commissioning, the high tech, security purpose, that is also a very tough issue for nuclear power plant. And also in steam power plant, there you can appoint some of the people, they are less experienced or less trained. But in nuclear power plant, as it is a very dangerous zone, and there small mistakes can happen and can make a very big loss. So very highly professional and highly trained people are basically appointed. So overall, these are the important things. And also, I discussed at the very beginning that the disposal of the waste or the byproducts, because those are also the radioactive products. So if you just dispose here and there, it will create problems. It will create problems in terms of environment, in terms of people. We all know that what the effect has done in Japan of Hiroshima and Nagasaki. No, they still people are affected by the radioactive done huge day years ago, but still the effect is there also. So the what will be the future of byproducts? That is also a very big problem, disadvantage. If you cannot dispose those byproducts and wastage on a proper area that the humanity will not be hampered, that is a very big task and big issues. So that is also a disadvantage, because we have to also care of it, take care of it. Finally, we'll solve one or two mathematical problems. There are two given here. I will solve one, and other one can be solved easily. So okay, if you read the line first, that an atomic power reactor can deliver 300 megawatt, basically the capacity of there, if due to fission of each atom, I mean, that means every atom, the energy released is 20 MeV, mega electron volt. Okay, each atom, mind my word, each atom, not total. Every uranium atom, if they uh, you know participate in the nuclear fission reaction, the energy that is released, that heat energy is released, that is 200 mega electron volt. That means mega means 10 to the power 6, electron volt means 10 to the power minus 19. Okay, so 1.6 into 10 to the power minus 19 electron, that is electron volt and joule equivalent. So calculate the mass of uranium fission, per hour. That means we have to calculate how much you know how much uranium we require for per hour, 1 hour, how much uranium we require for the fission reaction. So that we need to find out. So if we go from the very beginning, you see that 300 megawatt, that is the value we have given here. This is the capacity. The megawatt, first of all, if you just make it watt, it will be something like that, 3 into 10 to the power 8. And we also know that the watt is equivalent to joule per second. That means per second how much energy that is going to work. So that is also the equivalence. Watt equals to joule per second. Okay, that is the equivalent, the unit equivalent, joule per second. So this is for per second, but we have been told fission per hour. Okay, so this 300 megawatt is for per second. So we will now convert into second to hours. So how we will convert in an hour? How much seconds? It is 60 into 60, 3,600 seconds. So if we just multiply it with that, we get this total heat. This total heat is required for this 300 megawatt capacity in 1 hour. Okay, in hour, this is total heat. And we have also given that one atom, each atom, how much heat they generate. That is 200 mega electron volt. So if we make it a much more simpler expression, 200, then it becomes 3.6 into 10 to the power minus 12. You just put the value m for 10 to the power 6, and electron volt, 1 electron volt, we know that 1.6 into 10 to the power minus 19. Okay, so this is total 108 10 to the power 10, and the 3.2 into 10 to the power minus 11 joule, it is for 1. Okay, so we got total heat, we get heat for one atom. So if we divide the total heat divided by one heat for one atom, we will get that how much atoms have participated on that fission reaction on 1 hour. Okay, so we just divide the total heat by heat of one atom. So basically this is the total number of atoms participated in 1 hour. Okay, so we already got the amount of the number of atoms how that participated, but we told that what is their mass. We have to calculate their mass, and we all know that the Avogadro's number from the mole expression, that 1 gram atom has the 1 molar atom has the Avogadro number 6.023 to 10 to the power 23 atoms. And in uranium, that is the value is 2, the atomic mass is 235. So basically this amount of atoms, the weight is 235 gram. Okay, 235 gram. 235 gram, this is the weight, but we need this. So we just put the value here. Finally we get the mass per hour. It will be 13.17 gram only. If you just think that 300 megawatt is a huge energy, my student, huge energy. In my I can give you some of the examples that our hydroelectric power plant in Kaptai, that the capacity of that is 230 megawatt only. Okay, so you can understand that only 13.17 gram can produce so much energy. So that is the prospect. But the interesting thing is that also that you have to also um, get the risky factor also. So that's why there are some pros and cons also the nuclear power station. But still we are building, the peoples are building, and they are some of the nuclear power plants are also there in the whole country, whole world. So that's it. And one more example is there, which is almost same. So you just have a look. There is nothing critical here, almost same. So that's it for today, the nuclear power station. I think you understand that how the nuclear power station works. That is my main intention, or my main goal was to understand you that how the nuclear power plant actually works. Okay, the nuclear reactor, how we control their own, and we try to share some of the ideas. But when you go for the practical example by yourself, when you Google it, it will give you much more understanding for it. So I am unmuting all the students. If you have still any doubts or any questions, you can ask me. I have unmuted. Anything, anyone? My students, anyone?
Yes, sir.
Who? Hello? Hello? Who have the question? My student? My student?
শোনা যাচ্ছে তো আপনাকে?
My voice is clear?
Yes, sir.
Yes, sir.
No. Somebody asked that, sir. He has a question, so that's why I'm telling that. Who? Is there any question, my students? I've unmuted all. You can unmute by yourself. You have been muted by yourself. You can unmute by yourself. I have unmuted from my side. So if you have any question, still you can ask me. But I'm waiting. I don't think so. I don't think so. So I will suggest you one more time that please give your role in the chat box if you're new here just now, and also the task I discussed at the very beginning. Once it's back to the first example. Yeah, I will go back, no problem. But where is your question? You have also need to tell me. I need to know that where I need to discuss one more time. Basically,
Yes,
if
sir.
you where
Line.
where
108. How to get 108?
how to get 108?
Yeah.
If I'm not wrong, this is Hassan.
Yes, sir.
You are talking about this line?
Yes, sir. No.
that how I get 108. Oh my god, this is, you know, you see that the 3.10 to the power 8, this is joule per second, this is for per second, but in our question it is told that per hour. Okay, it is told that per hour. So if I want to find out the per hour, I also need the energy that is, you know, required for per hour. So this is for 1 second, and if I want to get, you know, for per hour, we have to find out how many seconds in an hour. We have 60 minutes in an hour, and every minute has a 60 seconds. So 60 into 60, there is total 3600 seconds. If you just multiply that, you will get this value. I think you're clear. Hello.
Yes, sir.
Okay. So, okay, I will suggest one more time that my student in the next week, not next class, because next class is Sunday. I will not talk about next class. It is, I will give you 7 days. You search, you take one nuclear power plant and make a presentation slide on that power plant. Okay, and give us the whole details that that maximum details that is possible are available in the internet, that how they are, how much where they, it is established, how much it is generating, what is the total number of units, everything. Okay, and for Bangladeshi students, there is no choice for you. You have to make it on Rupur nuclear power plant, that is, you know, establishing. There is available. It is available. Mm, available. I'm giving you some extra clue that it has 2 units. Every unit has a 1200 megawatt,
100,
2.4 gigawatt. Okay, the total capacity, and there are 2 units, 2 reactors. So these are the informations I am just remembering. Okay, so you search by yourself and get it. I think. Sorry, my students. These are the just. So that's it for today. I will upload this class lecture and your class and your overall video lecture, everything after your class. So till then, stay safe, stay home, and if you have still questions, you can ask me in your messenger group. I'm available there on. So till then, you stay safe, stay home. Next class, see you soon. Okay.